Yeah, hello everyone. My name is Tomasz Drwięga. I work for Parity, as you can see. How many of you has been on Sub-Zero and seen this, not this, but Offchain Worker presentation? So it was fancy subtitle last time. This time it's still no fancy subtitle, and it indicates that it's a little bit different than the one that we had in Sub-Zero. Yeah, so let's start off and let's build a draft of an oracle within Substrate. So we're gonna be building a Substrate palette, a module in Substrate that will store the BTC price. Okay, we will try to put the BTC price on chain, basically. And we're gonna do it like a very naively. So initially, I will start with I'm gonna publish the code, the whole code, as an example Offchain Worker module within Substrate repo, if anyone is interested later on. But I didn't manage to finish it on time before the presentation. But it's gonna be there soon. So we declare some storage entries in our Substrate palette. And we will store prices as a vector of U32. Okay. Then we have a helper function that will give us on chain an average price from that entire vector. Of course, we need to handle the case where the length of the vector is 0. Okay, because we can't really divide by 0. At least I don't know how. But yeah, we're gonna return none if there is if the prices vector is empty. Basically, what we want to build is just aggregate all the prices that people are submitting, and then taking an average and saying, oh, this is the BTC price currently. So we need a public function in our module as well. And in Substrate, when we are building a Substrate runtime, you do this by creating a public function within this declare module macro. So that function takes origin and takes a price. And then, as you can see in the very first line, how many of you are not developers? Okay. Pierre, I saw that. You're fired. Yeah, so the first thing we are doing, we are ensuring that the origin is actually assigned origin. So it's coming from someone. This is important because we want the people that submit that price on chain to pay the fees. Okay, so it's not free to submit price, so we don't want this we don't want to open up this huge DOS vector of people just submitting meaningless data. So we know who submitted what. And then what we do with that price that they submit, we just put it to this vector, but we keep at most 64 entries in the average. So the idea is that it's going to be like moving as long as the new data points are coming. As I said, this is a draft of an oracle. I don't want to. This is not a presentation about building an oracle, a price oracle on chain. So this is like super naive, that it has multiple attack vectors here. You can easily skew the price in any direction you want, but this will just serve us as an example. Okay? Yeah, so any questions so far? Okay, so we have this module that allows you to submit a price on chain. And on chain, we have this function that will return an average of the last 64 prices. Yeah, let's write a test for it. And you can write tests for this kind of function just by simply creating a test externalities in your test file, and then just calling the Substrate module directly without even thinking about blockchain. It's just Rust code all the way down. So we provide the origin. I actually didn't provide any. It's just like some number 0. So we start with average price none. We submit 27. So now the average price is 27. We submit 43. And now the average price is 35. Okay. So now the question is, how do you call that function? How do you ensure that the new prices are coming? This oracle depends on other people submitting the BTC prices on chain, creating these transactions that actually call that function within the module. And the idea, like the straightforward approach, is to build a separate application that will be listening to the blockchain client state, will be listening for some events over RPC. For instance, this watch headers events or watch events, and based on those events, we'll do some processing inside and possibly make some external calls because we need to fetch that BTC price from somewhere. And then at the very end, to feed the results back on chain, we'll create a transaction that will be submitted through another RPC call, submit transaction. Yeah, and it's a good way to do that. And it's really cool if you are the only entity that runs that node, because it's somewhere there on GitHub. You need to fetch the repo, you need to compile the application, you need to run it, probably monitor it so you know that it's actually working. If you want to convince more people to join you, you pretty much have to go like one by one and tell them, yes, please fetch that thing and run it. Maybe you can build some incentivization scheme in your module so that people get rewarded for submitting this price. Then it might be a little bit easier. If you want all the validators to be running it, it's going to be pretty difficult because you would need to go to each validators and convince them that it's worth to run your off-chain application. And then stuff will get way more complicated if you decide to do an upgrade. So if you want to change the code, change the URL that is being used to fetch this BTC price, then some people might update to this new version, some people might not, and they might not be happy because their nodes, they won't receive rewards anymore. And some people can be just plain malicious. What I mean by that is, whatever your off-chain application is doing, like the attack surface is what is in your module, right? So since my module just has a function submit BTC price, it doesn't mean that it only accepts a Bitcoin price, right? You can put whatever number you want there, and some people might use that. So what I want to say is that whatever happens off-chain, you still need to verify things on-chain. It's going to be the case for off-chain workers as well, but it's also a case for off-chain applications. So what are off-chain workers? So we want to move from this architecture, from this approach, to this approach. So we want to bring this off-chain logic, this off-chain computation engine closer to the node and actually make it really simple for people who run the node to opt in to run your off-chain worker. And how do we do that? In the same declare module macro, within the same module, we can create a function that is called off-chain worker, and this code will be executed as an off-chain worker, so separately from the block import, by every node that opt in to run off-chain workers. And by default, the node is configured in a way that every validator in the network is actually running off-chain workers by default. Yeah, and what this code is doing. So this code is printing a bunch of things. So it takes the average price, the function that we used earlier. It prints it on console just to show off that the off-chain workers are actually running. Then it prints a block hash, which is not really necessary. But then there is some magic happening here. So we want to fetch a price from some external service. And then we want to submit that price on chain. Okay, so pretty much whatever this off-chain application was doing, right now we will try to implement that as an off-chain worker within your runtime module. Yeah, so as I said, Offchain worker code is just part of your runtime. So whenever you have a palette that is part of your runtime, it can have an offchain worker there as well. As a consequence, it has direct access to the state. So you saw on the previous slide that I just called this average price function, and it returns some data that is just a state of the current block that the offchain worker is running at. As a consequence of this, it's also upgraded at the same time your runtime is upgraded. So if you want to upgrade your offchain worker code, you do a regular runtime upgrade, and every validator or every person that is opt-in to this offchain workers will run the new version of the code right away. And yeah, obviously it can work in standard and WASM environment by default, same as runtime. But with offchain workers, there might be cases where you actually don't want to run in WASM, and it's also fine. So if there is something you can't do in WASM, but would still be able to do, you can still write your offchain worker and use some native stuff, but then you lose this ability to like seamlessly upgrade the node. So the offchain worker will be distributed, but you have to upgrade your node as well to make it run. And what happens under the hood is Substrate node, after every block is imported, is just calling into the runtime and triggers the offchain workers. So it doesn't affect the block imports. It happens in parallel to the block imports. And offchain workers can take a couple of blocks to execute, and it's totally fine. As I showed earlier, any palette can declare the offchain worker simply by putting this function in the declare module macro. And yeah, there is some technicality there that doesn't really matter that much. Oh yeah, this thing is kind of important. So since the offchain workers can run for a pretty long time, let's say the offchain worker is running for 10 seconds because it's doing like 100 external HTTP calls, but your block time is 3 seconds, then there might be a situation when multiple offchain workers are running in parallel. Okay, so an offchain worker from block number 5 is running at the same time as the offchain worker from block number 6 because the previous one didn't finish yet. Yeah, so this is a slide that shows the offchain worker code, this high-level offchain worker code again. So let's kind of zoom in to this interesting part, so fetching the price, how we can do that. So this is fetch price function, and what this function is doing, it's using a special API that we have available for offchain workers to make HTTP requests, external HTTP requests. So we fetch the BTC price from the Crypto Compare API. We wait for the request to finish. So this will wait indefinitely. There is an API that allows you to wait with some timeout, with some deadline. So you can control how much time your worker is actually blocked on this request. And then if we get a status code of the 200, which means that the request succeeded, then we try to parse the response. And this is an improvement over December code that I was showing on the workshop because I was doing some hacky stuff to actually parse that JSON. But thanks to our friend at Parity, our colleague at Parity, we can now use cert.json directly within the runtime because it compiles in no standard environment. So we can just take the body of the response and we can parse it as a JSON value. And surprisingly, it doesn't increase the runtime code size that much. Yeah.
This all looks synchronous, blocking, I should say. Is there an async version of the same API?
So unfortunately, the entire runtime execution environment, WebAssembly, is single-threaded by design. So there is no way to like spawn multiple things. However, this API is not really blocking. So the only blocking call is over here. So here we initiate the request and we already ask the host, so the node, we ask the host to make that request. And this is where we wait for the response. And as I said, you can wait with a deadline, or you can just check if the response is there. So you can actually do other stuff while this request is being finished. Maybe it's not, async await yet, but with some effort, you can write a code that is actually not wasting too much time just waiting for the responses. Yeah, so we have this JSON parse, then we take the float that is in the API, and we convert it to a USD price in cents. And yeah, how is it possible? So Runtime has a bunch of APIs, but all of those APIs have to be deterministic because we want every node to process the block in the same way. However, Offchain workers are, like, by definition, doing external stuff, and by definition, they are non-deterministic. And because of that, we also extended the set of APIs that are available for Offchain workers to these additional things that I listed here. So, for instance, Offchain workers are allowed to make HTTP requests, but the runtime code is not allowed. If you try to invoke like the same host function to initiate HTTP request from the block execution context, it will just panic. Okay, so we keep the runtime deterministic, obviously, but Offchain workers have this additional APIs that they can use. Yeah, a test here. So there are some testing utilities to test Offchain workers as well. So you can instantiate test externalities, then register an extension, an Offchain worker extension, and this is where these additional functions are actually implemented. So by calling this function, you are saying, I'm in this kind of extended Offchain worker context. I call this fetch price function that is supposed to return a price, but it's making an external HTTP call. So in tests, I don't necessarily want to call the actual API, so I can mock the response and the expected request that the code should be making. So I say state, expect request with ID 0, and that request will be a get to that particular URL, and as a response, I want to return this. Okay? This is what the code gets over there when it's executed with these externalities. And the next interesting function is, okay, we have the price right now in the Offchain worker, but how can we put it on chain? So for this, we also have a set of extensions that allow you to submit transactions from Offchain workers. How much time do I have left? Okay. Yeah, sorry. So what I'm doing here, I'm using a call enum, and I'm wrapping the price in this call enum, which is auto-generated by this declare module macro. So I want to call the submit price function. I put it to a thing that is called submit transaction, and I submit a signed transaction. And then, yeah, I display a message if it got sent correctly. So what key is used to sign these transactions? That's the question. We can create this call easily, but then how do we sign and how do we make sure that some key is available for Offchain workers? So we have this idea of application-specific key files that are floating in the key store. So our module needs to define the special key type that will be unique to that particular module. Then we need to create this application-specific crypto types wrappers. So we use an app crypto macro. We pass a cryptography that we want to use. So this time I'm using SR25519. I can use ED or ECDSA. It can be different. So the crypto stuff should be the same as the crypto that is available in your runtime. So since we are submitting a signed transaction, and if you are supporting only SR, then you should use SR here. But the default runtimes that we have, they allow you to use different cryptos. So pretty much you can choose whatever crypto you want if you are using this multi-signer account. And then we need to pass this special extension to submit transactions. That is, so this is part of the module declaration, but we will be passing a concrete instance of the submit transaction on the runtime level. So this is just like a glue code that we need to be able to send those transactions. This is what happens in the runtime. So we pass the submit transaction. It's created through transaction submitter, and we say, this is actually taken from I'm online, but you can see that I'm using this crypto module with application-specific crypto, and I pass this as the account IDs that should be used by that module to sign transactions. There is even more glue code, but luckily this is something that you do once, and all other off-chain workers or all other modules that want to send signed transactions can do that, can use the same thing. So we need to teach our runtime how to create transactions that will be later on processed by our runtime. So the runtime is only able to verify that the transaction is the one that it expects, but currently, like without this, we don't have any primitives that allows us to create an actual transaction. Yeah, so we instantiate a bunch of things. We instantiate signed extensions. We can set some tip if we want our transaction to be included faster, but obviously we will have to pay more for the transaction fees if we do that. Yeah. Any questions so far? Okay, cool. Yeah, again, we can write a test for this too. So if we expect our off-chain worker to submit some transactions, we need to instantiate a bunch of externalities and extensions to those externalities. So namely, we need this transaction pool thing. And then if we call off-chain worker, we can check that this is not a real transaction pool, but this is something that we mock for tests, and it allows you to check that 2 transactions has been submitted by calling this particular function. So why these off-chain workers might be useful? So we have one example here that we kind of covered. So we can we can create some price feeds. And the value proposition of off-chain workers is, yeah, you can pretty much do everything as an off-chain application, and it's probably going to be simpler because you know the tech. It's not blockchain. You just communicate over RPC. Maybe the hard part will be to create the transaction, but the rest will be super simple because you can connect to whatever database you want. You can use your preferred HTTP library and so on. But the value proposition is, if you want everyone to run your off-chain workers, then it's much easier to convince them to just flip a flag in their Substrate node than to ask them to install some external software. And also this upgrades, if you plan that this code is going to be upgraded, and I guess no one really knows a software development project that was never upgraded, then yeah, it's a good idea to maybe put it as an off-chain worker. Yeah, a couple of examples here for oracles. Then heavy computation. This is definitely something that you don't want to do on-chain. You don't want to do during block processing because if it has to be done by every node in the network, yeah, maybe it's like so important, but there are some cases that are not really that important, or rather are hard to compute but are easier to verify. So for instance, fragment election, this is like an optimization process, and we can do more rounds to get a better solution, but obviously doing more rounds takes more time, and this is something that we can offload as an off-chain worker as well. So when someone finds a better solution to the current validator/nominator distribution, they can just submit it on chain and collect some reward for that. Yeah, pretty much any unbounded enumeration or computation should be offloaded as an off-chain task. Yeah, indexers, this is something that is interesting, but we need to extend, we need to introduce a bunch of changes to how the current Offchain Workers work, and that's something that is listed here as Offchain Workers 2.0. So this is like a rough roadmap of what we have planned for Offchain Workers. So firstly, we want to parallelize the workers within the runtime itself. So if we have multiple modules or multiple palettes in your runtime, and they all declare Offchain Workers, probably it's a good idea to run all of them in parallel instead of sequentially. Then there is a special database that Offchain Workers can use, and it's not the state. It's separate only for Offchain Workers communication, and it doesn't have such a nice API as the state database has. So through this declare storage macro, and it might be a good idea to have something like that for Offchain Workers too. Yeah, and some additional improvements over there. So let me focus on the big things. So currently, Offchain Workers are only run when you are fully synced with the network. So when you are syncing, so let's say you start with Genesis and the network is at 6 million blocks, you don't really run the 6 million Offchain Workers that were in the past, because we assume that the use cases will be, I am fully synced and now I'm doing some useful stuff. Probably the HTTP calls that you would do for block 1 would be completely outdated. Maybe the API endpoints doesn't exist anymore. So we don't run Offchain Workers during major sync, but there are cases where that would be useful. So this indexer case where you actually run the node, you sync the node, but then the Offchain Worker is, for instance, populating some MySQL database, would be an interesting case if we were able to run Offchain Workers during this major sync as well. Yeah, and Offchain Workers 3.0, currently workers are kind of attached to a particular block that they are running at. And the idea is to detach them from the blocks, so they run sort of concurrently to the entire client, and they only process events from the client. So instead of on every block running an Offchain Worker, we just inform the Offchain Worker that is running for a very long time that a new block was imported. What that gives us is that this Offchain Worker code, this Offchain Worker 3.0, is now able to see like beyond blocks. So it can take some data from the block, 500, and then compare it with a block like 1,000, and then figure out something that should be done. Also, that would allow us to move the Offchain Worker code off-chain as well, so separate it from runtime, and for instance fetch from some other storage. And it's also important because then the runtime code gets smaller because the Offchain Worker code is separate. Any questions? If we have time for any.
Thanks for the talk, Tomek. You said that nodes are opt-in for off-chain workers. Just wondering if there's like an incentive for them to opt in.
So it depends on the off-chain workers that are within your runtime. By default, we have enabled validators to run off-chain workers, because a couple of palettes that we provide as part of Frame actually depend on the off-chain workers running for validators. So I'm thinking about I'm online palette. So the idea is that you have a huge validator set and say 10,000 validators, and only 1,000 of them will be able to produce block during that particular era. But how do you know if the rest 9,000 is offline or is just didn't have a chance to produce a block? So this other 9,000 can send this heartbeat message and say, hey, I am online during this session, but actually I didn't happen to have a chance to produce a block. So we don't penalize them for not being offline. And this transaction, this heartbeat transaction, is actually generated by an Offchain worker. If we are speaking about people who are not validators, then if we have this kind of more sophisticated Oracle module that I showed today that is incentivizing this price submission, then yeah, you opt in because you can earn some money just for making HTTP requests, right? Any other questions? Yeah, there's one out there.
So just around security, around the automatic upgrades, is the execution environment limited to only like, what kind of external things can it do outside of the WASM? Because if you have like automatic updates and you have like, you don't want to have like random code randomly updating.
Yeah. So yeah, so security-wise, the Offchain worker can't do anything. It still runs in the sandbox WASM environment. Like obviously there's this optimization when we run native code if the runtime version matches the node version, but let's focus on the simplified case where we run the WebAssembly. So WebAssembly is running in a sandbox, and only the functions that the host provides to that sandbox can be called. So I had this one slide that was listing these additional APIs that the node can do, and this is pretty much everything that can be done from the Offchain worker running in WASM. So you can do external HTTP requests, but we don't expose, like, I don't know, the TCP stack. This is just like, it's still low level, you know, for a web developer, but this is HTTP low level functions that the host is supporting. So you can start a request, you can add a bunch of headers, you can write a chunk of body, you can read you can read a response, and so on. So we are still limited to what the host provides. And this is, from the security point of view, this is cool because we have this secure sandbox. And if you review the code, you know that it can't escape the sandbox, or rather the Offchain workers are only limited to do this stuff. But at the same time, it's sort of a drawback because it means that you can't really import a request library like this popular Rust library to make HTTP requests because that library is using, you know, some low-level TCP API to initiate the request. And this is not available in WASM, so we need to come up with some, you know, wrappers that people use instead of the libraries that they might be used to. Okay, so thank you very much.